Hello! In this video, we're going to look at solving problems with free-body diagrams and Newton's second law, taking lots of different pieces that we've been learning and putting them all together to solve some problems. Here we go. First, a quick review. We have this beautiful flowchart here. You can use this from either side when we're thinking about the relationship between force and motion. A big thing to remember is that force does not cause motion. Many people think that if something is moving, something has to be pushing it, but that's actually not true. Force doesn't cause motion, force causes change in motion. For example, if you look from the left side, you can see that if the net force is 0, the forces are balanced, then the acceleration of the object is also 0, and so the velocity is constant. However, if the net force is not 0, the net force is something, so the forces are unbalanced, then the acceleration will also not be 0, and the velocity will change. You can also use this diagram from the right side. How is the object moving? Is the velocity constant or changing? And figure out the force based on that. Let's put some names to these ideas. The red part of this diagram, that's Newton's first law. When the net force is 0, no outside forces, then the velocity is constant. The object will either stay at rest or continue moving with constant velocity. The blue part of this diagram is Newton's second law of motion. And more specifically, the relationship here is that the net force equals the mass times acceleration. That equation is Newton's second law of motion. Here's an example problem so we can practice using this. We have a teacher going skydiving, and there is a drag force. How many forces are acting? What is the net force? What is the acceleration? And describe the speed. Here's how I would work through this problem. Step 1, we're talking about forces, so let's draw a free body diagram. So here's a 75 kilogram box, that's going to represent our teacher. And let's see, which forces are acting on the teacher? Well, the person has mass. Oh, we also know that they're moving down. They're falling down from a plane going skydiving. Okay, so we know that they have mass. That means that the Earth is pulling them down. That's the force of gravity going down. And the problem also says that they experience a drag force of 490 newtons. Many people think that the force of gravity is the same as the mass, so a lot of people want to put 75. That's wrong. A lot of people also want to say that gravity is the same for every object, so that gravity on Earth is 9.8. That's also wrong. In fact, the force of gravity is the mass times the acceleration due to gravity. So that's 75 kilograms times 9.8 meters per second squared on Earth gives us a weight of 735 newtons. That's the force of gravity pulling the person down. So now we have the two forces. There are no sideways forces acting on this person, so we only have the two forces to think about. Next question, what is the net force? To find the net force, we're just going to combine all of the forces, but direction matters. We have no horizontal forces to worry about, so I'm just going to add the vertical forces. We have 490 up, 735 down. I've made the down force negative. So we combine those and we get 245 newtons. The negative here means down. So I can redraw this diagram, right? These two diagrams are the same. In the right version, I've diagrammed out each force separately. In the left version, we've combined both forces to have one effective net force. The net force isn't real, it's just the combination of all of the forces that are acting. So we have the net force, magnitude 245, direction down. Next question, what is the acceleration? Let's use that equation. The net force equals mass times acceleration. Rearranged, acceleration equals force divided by mass. Plug in some numbers, and there's our answer. Notice that the negative here also means down. So the net force is pointing down, the acceleration is also pointing down. Because of this equation, the net force and acceleration are always going to act in the same direction. Because the velocity is down, and the acceleration is also down, that means that this object is speeding up, going down. I hope that was helpful. Have fun with Newton's second law.